In the next presentation, we're going to explore the power of participation in terms of how social exchange helps to pass along information that engages people in activity. And for this, I'm very happy to introduce to you Damon Centola. He's Associate Professor at Annenberg School of Communication at the University of Pennsylvania, and there he directs the Network Dynamics group. He's currently a fellow at the Stanford Center for the Advanced Study of Behavioral Sciences, and he's going to talk to us about the spontaneous emergence of, and this is the suspense part, of ideas and stories. So Damon, thank you very much for sharing with us some of your mathematical modeling approach to the way that interaction and social exchange encourage the power of participation.
So I'm going to talk about how behavior is spread through social networks. And when we typically think about that kind of a problem, we start with something that looks more or less like this. Right, this is something we all have in our heads. There's a large social network of people connected to people. There's a complex sort of topology that connects them all. And we think of them all in kind of an initial state where they're all off. Right? No one's doing anything. And there's a seed person or an activist. And that person is sort of trying to initiate a kind of a diffusion process through the social network. And we can talk about a flu spreading, or we can talk about a social norm spreading. We can talk about beliefs about vaccination, or even about beliefs about climate change. And we tend to think of this process as kind of evolving just as a binary decision. As you weren't doing it, it was introduced into the population, you have the option, you either adopt or don't adopt. And most of the work I've done for the last 7 years has been focused on this question. How does the structure of the network affect this process? And we also ask questions about where can we seed, right? Where's the optimal place to put in a new idea or a new contagion to a network to get it to spread? What I'm going to talk about today goes significantly beyond this question. Right? So I want to ask about our behaviors that aren't defined by a single external contagion being introduced into a population, but rather behaviors like social norms, like beliefs about vaccination or beliefs about climate change, the kinds of diets, the kinds of exercise patterns, the kinds of screenings that we all get. These are things that aren't just an option that's presented to us. They're decisions that we make based on our interactions with other people. And we're constantly evaluating which behaviors to engage in. We think about practices like how to greet people, practices like how to engage in bargaining, right? What's a fair outcome? These are things that aren't established from outside. These are things that we establish through kind of an endogenous social evolutionary process. And when we think about this process of social norms, it really relies fundamentally on expectations. What I think you're going to do, and more importantly, how I perceive your reactions to me. And I revise my behavior based on that. And then you revise your behavior based on the decisions that I've made and so on and so forth. And we form these sort of beliefs and expectations about each other. And ultimately, this process of individuals all sort of engaged in this sort of pairwise interaction can aggregate up to form a social norm. The most amazing thing about these norms is that once they appear, once they become stable within a society, they appear incredibly concrete. They seem as if they couldn't have been any other way. And they appear normative in almost a moral sense. Right? That this is the way we should engage. This is what's polite to do. What stands in stark contrast to that, of course, is the fact that across so many different cultures, the norms about politeness are so different. The norms about how to greet people, the norms about bargaining and fairness are really different. And so this tells us that there's not actually a right answer as much as there is a social process that gives rise to it. And this is the process we want to understand. Interestingly, there's been a lot of work on this question by economists that have emphasized, and sociologists as well, that if there is a norm in society, if there's a behavior that we all just sort of do and it's reinforced socially, it must serve some social function. Ken Arrow in the economics department here has been a huge contributor to this literature, but interestingly in the 70s he argued that all norms are essentially functional. They solve social dilemmas, that's what they do, that's why they exist. Right? And in the decades since then, that became kind of a focal point for a lot of research. In the decades since then, a lot of people pushed on that, including my own work, showing that not only can norms emerge that nobody wants, but norms can emerge that are specifically welfare reducing. They're worse off for every individual and also worse off for the collective. Nevertheless, people can all participate in them, and then they can all enforce each other to do them as well. And so we want to think about this more generically as a social process that leads to basically social lock-in. And when we think about the kinds of examples, we have, of course, linguistic norms, the kinds of linguistic practices we all engage in. We have greetings, beliefs about politeness, monetary exchange and fungibility. What is appropriate to use money for? Right? If someone helps you carry your bag, to your hotel or up to your room, it's appropriate to put some money in their hand. If a friend helps you move a couch, it would be really weird to then slide a 20 into his pocket, right? Why? And these, again, the point about these norms is there's no binary decision. You're not saying money, no money. You're thinking about this interaction, what's appropriate, not appropriate, and there's a huge variety of possible equilibria in this space. In fact, it's fair to say an unbounded or even infinite variety of possible norms that could exist. Right? Nevertheless, we've all sort of agreed on one, and we all feel like it's right. It's just wrong to give money in this case and just right to give it in that case. That's always a signal that there's something sort of normative going on in the background. Of course, we see this with gender conventions as well, which have evolved dramatically over the last 40 years. Nevertheless, we still see some tremendous entrenchment on gender conventions within organizations. And again, this has at its base a kind of social expectation that's rooted in this process of people developing beliefs about each other's behavior. And we see this also with coordination and collective action. What kinds of collective action are appropriate? What kinds of issues or topics do we take up? And what kinds of methods, right, do we pursue? Are we eco-terrorists, or do we engage in peaceful social protests? And all these things emerge as norms within a society. Of course, the question when we consider all of these examples is, where do these things come from? And this is what, over the last 200 or 300 years, a tremendous amount of ink has been spilled on this question. And there's three sort of big answers. One is that there's some kind of central authority that tells us all what to do. The second one is that each of the options has a different payoff associated with it, and we all know that. And so we all kind of gravitate towards one of the options. And the final one is essentially that there's some kind of feedback informationally about what other people are doing. And using that, we all evaluate what the best option is based on popularity, and that creates a reinforcing dynamic. Now, when we think about this question from the point of view of central authority, and may sort of consider each of these three in turn and show you why we actually need a different solution. The centralized authority basically assumes that there's an incentive structure in place. Right? There's a government that wants us to do something. And this of course, does happen. Right? Governments incentivize or de-incentivize having a certain number of children. And organizations do this as well. They encourage certain behavior, certain dress codes, certain styles of interacting that then are translated directly into promotion and social reward. Right? And people who deviate from this are excluded. And so there are these kinds of incentives in place. The question for us is whether or not they're always in place, and whether just because they're in place that tells us the whole story. Right? So there's a really interesting example with an incredibly simple social norm, something like driving on the left versus right-hand side of the road. This is as basic as it gets. It really doesn't matter what you do. What it matters is what you do with respect to everybody else. Right? If everyone's driving on the right, you really want to drive on the right, and vice versa. Right? So this is the kind of thing that we just think of as a government mandate. They tell us what to do and we do it. There's a rule essentially in place. The country of Sweden in 1976 decided to switch from the left-hand side to the right-hand side to accommodate the rest of Europe. So this is a risky thing to do, but so they, for about 4 months ahead of time, advertised that they were going to be doing this. And then on the night of September 2nd, they shut down the entire roadway system for the country, repainted all the roads, redid all the signs, and then opened for business on September 3rd, and everyone tried to go to work. And what wound up happening was something that looked more or less like this. It was just utter chaos, and the country of Sweden didn't function for about a month. Right? People couldn't figure out what to do. And that's really interesting because everyone knew what they were supposed to do, right? There was a rule in place. So what went wrong? What went wrong is that if I'm driving on a stretch of highway, it doesn't really matter what the people in the city are doing. All that matters is what those headlights coming towards me are going to do, right? And if I think that that person may have forgotten or is going to deviate slightly, so I see their headlights just ever so slightly move towards the left, then I'm going to respond in turn because all I care about are my expectations for that person. Right? And this tells us something about how norms really function. The fact that there's a rule in place doesn't mean as much as the people that we're interacting with and how we coordinate with them, right? And so if I tend to respond to this person by then moving back towards the left, and that person's making similar expectations and judgments about me, right? And this process evolves, and everyone's doing this in a whole interconnected way, and it evolves into chaos. So a kind of solution other than this one, because this one tells us that something else is needed in addition to just central authority to generate large-scale social coordination, is this one, which is essentially that there are some differences in the payoff. So Harsanyi and Centola won the Nobel Prize for this in 1988. They basically argued that, look, in these situations where there's lots of different possible equilibria, lots of sort of social outcomes that could emerge from a given initial state, there's an option that's either a higher payoff, and everyone can kind of see that about it, or there's an option that's less risky, and then everyone can see that. And it's a really good solution, obviously. It solves a lot of problems with coordination dilemmas, but it eliminates the entire class of problems where we don't know what the payoffs for the options are. And it also eliminates the class of problems where new options are popping up continuously. And so when we think about norms and collective coevolution, people can spontaneously suggest options. We can respond to each other creatively. And in that space, this theory doesn't give us any sort of traction. Furthermore, who knows ahead of time what the payoffs for every possible behavioral option are? Right? And that's just a tremendous institutional assumption that we would have on the ground. So again, a new solution is required. And this is the thing that most social scientists tend to think about today, is something like a bestseller list, right? Or a voting system. Right? There's some kind of polling that samples the entire population and then reports back to all of us what the state of the world is. And then uses that basically as a centralized repository of the kind of global behavior. And we are all paying attention to that signal. But again, think about the thick institutional overhead to make that work. We have to be able to sample everyone in the population and report it back in real time. Furthermore, people have to be paying attention to that signal. And it has to be intelligible. We have to know what it means to that behavior. But when you're thinking about what sort of preventative screenings to use, or what sorts of diets to adopt, or whether or not to go to the gym today or not, these are all sorts of real-time decisions we're making, probably more based on the kinds of interactions we're having and the kinds of behaviors we're able to coordinate locally than any kind of list that exists. And furthermore, if we want to ask the question, how does this process get off the ground in the first place, we can't really assume that there's all this institutional infrastructure in place to solve it. So this is what motivates the evolutionary approach, which is what I'm going to talk about today. And a lot of people have thought about this for a few decades, but really with Peyton Young in '93, this literature really got off the ground, where he really thought about this question of the evolution of conventions as a question of aggregation from what's called micro to macro. So basically it means if you give people these individual level interactions and they have no sense whatsoever of the universe they're in, of the size of the population or what anyone else is doing, but they're just concerned about how to coordinate with their neighbors, how does that process ever aggregate to everyone in the community doing the same thing? And the interesting thing about all of the models and all of the work that's been done on that since is it's all mathematical theory. And of course raises the question, well, what happens empirically? Can we even study this empirically? This is incredibly difficult to study empirically. And the reason why is because we are already always in this historical stream. We have norms governing everything we do. And so the question is, can we step outside of it and watch this process take hold? And we have examples of new norms being created all the time. Think of the word like spam. Right? We use the word spam to refer to junk email. That is such a weird thing to do. And why do we do it? Anyone know why? Right? There's lots of possible explanations. Monty Python had a skit. Right? And one of the reactions that people give to this is, well, the reason we do it is because it's on Gmail. Right? Gmail has a spam folder. But this is exactly the point. Right? Gmail did this after it was a popular phenomenon. Right? It was some sort of social process gave rise to this sort of convergence on the word spam. Then Gmail institutionalized it by having it on their spam filter. But now when we try to tell the story of where does it come from, that institutional signal becomes the dominant way of interpreting whatever the social process is. So this motivates a sort of a new way of doing this. So this is the methodological approach I'm going to take here. I'm going to talk a little bit more generally about it. But the idea essentially is to run experiments, instead of on individuals, to run experiments on entire societies. Right? So if you have 100,000 people connected in a network, and you want to understand if they collectively produce a social norm, that is inherently and by construction an interdependent social process. Those people are not identically and independently distributed in your data set, which means at the end of the day, you don't have 100,000 data points. You have one data point, which is the social process that gave rise to that norm. In order to study this in any kind of systematic way, you'd have to be able to create entire societies and replicate them and watch this process emerge again and again and again and again. And what I'm going to show you today is there's actually a way of doing that. You're going to watch it happen in real time. And then the argument I want to make is that not only can we study this process, we can control this process. By structuring how people interact with one another, we can control whether or not this process fails and people all sort of disagree with one another, or this process converges and everyone agrees. And it has nothing to do with the options available in the population. It has only to do with how they're connected with one another. To maybe a little bit of theoretical background on this, and then get right into the experimental design and the empirical findings. So theoretical background for this is these models of sort of the evolution of social conventions. And there's three networks here that kind of define the range of possible network topologies. And this is really important because when you look at this, these all seem like kind of contrived. And they are, because they define endpoints in the space. But when you're used to looking at networks, particularly these pictures from the web, they're these sort of complex, right, interacting multidimensional spaces, or they're these scale-free networks with hubs and spokes and so forth. The important thing to know is that this network, the lattice, is the extreme of an ordered regime. Everyone has the same local structure as everyone else, and it's got a dimensionality defined by that ring, which is it's a one-dimensional network. It's the lowest possible we can get. When we move over here between this space of an ordered regime to a random network, where everyone still has 4 neighbors, but the ties have been randomized, now we have an infinite dimensional topology, but still we have local connectedness and a limited number of people you interact with. So the small world model, for those people who know that, exists in this continuum between here and here, which means the results that happen between this space are all constrained by those 2 endpoints. So all we really need to know is what happens at that point and that point. Furthermore, over here, this is just a random mixing space. This is just you pick a neighbor at random, interact with that person, put them back, and try again. And this is the kind of default physics model. The mean field model is the sort of way that we approach the things over here. And there's no real social structure. Between the random case and the mixing case is where the scale-free networks exist, networks with lots of hubs. Right, so the kinds of complex topologies that you have in your head are all sort of constrained in this space. And what we'd like to do is understand what's happening in each of these so we can understand more generally what's happening with this process. So the way that we study this in the models is to come up with a game that models this social process. And the way that we do this here is with what's called the name game. So 2 people interact. They're basically assigned to interact with each other, their neighbors in the network. And they both see an object, and they want to come up with a name for it. But they've never interacted before, and they don't have any history with this object. So how do they coordinate or communicate with one another? And so what happens is they both sort of simultaneously suggest options, and inevitably their first choices are wrong. But then they try to coordinate over a series of sequential interactions. And through a process of trial and error, eventually they come to consensus. And the question is, how does that local consensus aggregate? Do you get competing groups, or do you get sort of universal agreement over the network? So in terms of studying this empirically, it's extremely hard, as you can imagine, to study that kind of real-time creative process evolving between people, but then across the population as a whole. So a lot of the empirical people have kind of gravitated towards doing work like this. So this is like a top secret photo from Sony Labs, which, why am I allowed to show it? I don't know. The guy who gave it to me, then I saw him use it in a presentation, so it can't be that top secret. But essentially, this is what they're doing, is they're putting robots together and they're playing the naming game. They're pointing at objects and they're trying to coordinate, right, on linguistic convention for those objects. Now, the curious thing about this is, okay, let's say they solve it. What does that actually tell us about human communication? There may be some interesting story about what that means for the cognitive process of language learning. I don't know what that tells us about social norms more generally, because the problem here that we're interested in isn't in how 2 people communicate. It's how that process aggregates. If A and B are interacting, but B's also got to coordinate with C, and C with D, and D with F, and then Z with A, right? How does that process aggregate when everyone's maybe coming up with local norms that don't exist with or don't coordinate with everyone else's norms? So this is what motivates the sort of new empirical method. When we study these kinds of things, as you can imagine, studying large groups engaged in kind of a spontaneous behavior, it's extremely difficult to get a grip on this process. So here, this is something that kind of harkens back to all the work that was done here at Stanford and then also at Harvard and MIT in the 50s and 60s on small group labs. Right? People put, essentially it was like 2 people or 4 people into laboratory groups and had them play these games. And it's incredibly interesting data. It's so rich. People are extremely creative and incredibly competent at figuring out what each other mean and coming up with really entire new linguistic forms just to solve problems. The issue is, and this is a really interesting and general problem for research in this area, is that with all of these sort of social aggregation processes, below a certain critical point in the size of the population, the dynamics have one qualitative answer. Above that critical point, they have the exact opposite qualitative answer, which means if you study populations below that critical point, that work doesn't tell you anything about populations above that critical point, right? So all of this really excellent, and it's fun to read too, it's very smartly done. This really excellent work that's been done with small lab groups doesn't tell us anything about what happens when you move to 100 people or 1,000 people or 100,000 people. Now that's the downside. The upside is that when you move to an experimental space, you want to study these things, you're not limited by having to study huge populations. You only need to identify populations that are above that critical point. And once you're above that space, the results and expectation generalize. So in this case, for this study, the critical point for these models is around 20. Right? So if you studied with 18, you get a different answer than with 22. It's a really discrete and specific cutoff point. And then once you're studying 22, that should generalize to 100,000 or 100 million. Right? And that's extremely valuable for us experimentally to know that. Then one of the things that has been done recently by economists trying to study slightly larger groups is to have people play real-time decision-making games. And this is much like the Harsanyi-Selton thing. There's people with an A and B option. We know the payoffs and are able to coordinate. Crickets. And so the problem with these, however, is that these don't study the real-time evolutionary process of people creatively responding to one another. They study how people make choices with like really specific institutional constraints. What we want to do is take away those institutional constraints and study this evolutionary process. Of course, one of the things that people want to do these days is go to big data, and that's a solid intuition. It's a good idea, and there's a lot of available resources to do that. The issue for us is that we'd like to study how social structure controls this evolutionary process. Right? Unless we can eliminate leadership or exogenous influences, social control, all these factors, unless we can eliminate them, we have no idea what's happening, right, causally. And so this is why experiments are valuable. And then finally, as I mentioned before, what we'd like to do is not just study this process once. We'd like to be able to replicate it so we can really study the systematic evolution of behavior over a network. And so the method that we use here could be called a social petri dish, sort of a go-to trope. But you can imagine structuring populations in a way that's invisible to the people in those populations, right? And then you'd watch the sort of evolution of behavior, and in one case you'd see collective behavior emerge, some sort of coherent dynamics. In another case it would fail. And much like what we see in biology, once we can do this, we can replicate this, right? We should be able to systematically generate the emergence of collective behavior. So the name game is exactly like the name game experiment, the sort of design we use for the empirical collection is exactly like what we had in the model. So people look at an object, they have to come up with a name for it. In this case, it's a face. And they interact with others in the community to see whether or not they can coordinate locally. And our goal is to see how the pattern of interaction affects coordination globally. So when people arrive to the site, now I recruit from around the World Wide Web. So we send out like hundreds and hundreds of advertisements and emails, and people come at a certain time. And they sit on this waiting page, and they're given a kind of little demo of what's going to happen. They sit there and they wait and they wait and they wait, and then essentially the network's fill. We get enough people to run a game, and then when the game starts, it looks like this. This is the actual game interface. I started running this when I was at MIT. So you see a name of all of your players, and then you see a face, which is the object you're trying to name, and you type in a name. And here you see the round you're on. So this is going to be 20 rounds, and you're in play on round 1. You have a time limit, you have 20 seconds to play, and there's your name. And essentially, this is it. This is the entire experiment. It's just watching people play this game repeatedly. A couple of things. Regardless of what network structure you're in, you see this list of players. So that list doesn't tell you anything about who you're connected to, or whether you're interacting with the same person again and again and again, or with strangers every time. You don't know. Right? And as this evolves, the only signal you get is that when the other person puts in their answer and you submit yours, it tells you whether you matched or not. And if you didn't match, you get to see what the other person put in, although you don't know who they were. And if you did match, it says match. Right? So you're learning this history of what the other options are in the population. And you can imagine being in that situation and whether you would sort of go with the ones that were successful, or if you started failing, whether you would now try new options. People can put in anything they want here. I mean, I ran this initially at MIT, which was a huge mistake. So people would type in code. People copied and pasted code and tried to like hack into the system. So when you like list the names that were coming up, there were like whole code snippets that would show up. There wasn't any real problems with profanity. That's like classic thing. No profanity problems, but problems people putting in code. That doesn't usually happen. And so this is just an open text field. And so by construction, there's an unbounded number of possible norms that could emerge in that space. Right? Does anyone have any questions about this? I'm going to show you the results now. So this number is completely arbitrary. Right? I'll show you that the networks we use are quite a bit larger than that. But I didn't want to signal population size. Right? So everyone sees this regardless of the size of the population they're in. Yep. Yeah, this is the face you're seeing, and you're literally typing in a name for that person. So Kelsey would be a real live entry into the game. Yeah. Well, they're faces, yeah. It's kind of object. Yeah. Anything else? I just want to make sure when I play the data, you'll understand what people were doing. Right? Okay. So what I'm going to do now is show you the raw data. People never do this, and the reason they don't do it is because it's always super risky. But in this case, we don't need to do a logistic regression on how network structure affected percent coordination. We can just literally, and this is one of the things I think that's huge about this sort of method, is we can just watch this process unfold in real time. So what's going to happen is I'm going to hit play, and then each of these nodes is a person. This is a network of 24 people. And when they choose a name, it's going to light up with a color. On the right-hand side, there's going to be an index corresponding between names and colors. And again, remember, people are putting these names in, so that list is going to grow in real time as people put in new names. And there's going to be a bar associated with that color, which is the number of people doing it. So you can see a sort of histogram of how popular the name is becoming. When people interact, a line is going to form between them. And this is a lattice network, right? So people will only be connected locally. And then we'll see by the color of the line whether they matched or not. If they matched, then the line will be the same color as the color of the nodes. And if they didn't, it'll be a white line. Okay, so what you can see here is there's a ton of names coming in, and there's already some coordination up here with the name Sarah, and some coordination down here with the name Elena. You get some sort of local groups forming. And then you have some groups here on the side that are sort of disagreeing. You've got Julie over there, and then I think Samantha over there. Interestingly, you can see these people on the border regions who are connected to people who are inside and outside the group, and they're sort of struggling. Because when you're inside a group, if all of your neighbors are adopting something, then you sort of stick with that. But if you're on a border, you're sort of seeing signals go back and forth, and the question is, how do you handle that? You try to accommodate neighbors on both sides. Some people just, you can see, just randomly change the option that they're using, right? So instead of trying to accommodate what's on the left or right, they get frustrated and they just throw out a new name into the population. You can also see that some of the options that people chose were like gorgeous or sexy or beautiful. Right? I think of these as attempts to cheat. Right? Instead of naming it, they were throwing up these categories, or blue eyes is another one. But interestingly, that didn't affect anything. That is to say, running it in this network always generates this kind of dynamic where you get groups forming and the groups are competing independent of the options that are available in the population. So it's not just having a good option that counts. It's the dynamics of interaction. So the question for us was, well, but how do we get coordination off the ground? Is there something we can do to the network? So the next thing we did was look at the random network. So now people are connected across the population. They still have a subset of interactions. And the key thing about this is because it's a random network, information can flow much more quickly from each side of the network to every other side. So when we watch this evolve, we see something that looks really similar to what happened before. Some groups start to form. This person and that person and that person. They start to form like a little social cluster. And the social clusters compete with the other social groups. But so far, no group has really sort of gained tremendous traction. Lisa and Sarah, Jane, Jennifer, and Julia become the sort of dominant names. But none of those names take off and become a big winner. Right? And so this is an interesting point because we see big winners all the time in society. Everyone wants to know how to make their song or how to make their star the big winner. This is telling us this isn't a really hard problem, actually, when people are making these decisions based on what their neighbors are doing within social networks. So we decided to pursue sort of one final option, and this is the homogeneous mixing case. The dynamics are exactly the same, except each time that people interact, they're picking a stranger. And because there's a limited number of interactions, an expectation they'll never interact with the same person twice. So each time they're seeing a tremendous difference in the signals they're getting. And what you see very quickly is that the name John sort of takes off and starts to gain some sort of traction in the population. And then very quickly, it starts to saturate the network as a whole, which means that two people who never interacted, total strangers, meet for the first time, and they both nominate the same word. Right? This is like two strangers meeting for the first time and both knowing how to shake hands, right? Or both knowing how to greet each other. And more generally, when this takes off, we know that there's no way of coming back. Once a popular winner gets entrenched, it becomes socially reinforced throughout the population, and all other options die out and go to extinction. So that you can see this was a male name. These were all run with male and female names for gender parity. It didn't make a difference in the dynamics whatsoever. So when we compare these dynamics to the model, the really sort of striking thing is that they don't just look similar, they look identical. Right? If you look at the people's behavior here, this is a time series of the popularity of norms with all of the norms sort of down here. Again, a time series and again, a time series. And what you see is that basically some norms have got about 40% popularity, and again here, but none of them took off. And when we think about this critical mass phenomenon, the question we almost always ask is, how large does the critical mass need to be How much popularity, how much groundswell do you need to get a norm to take off or to get a thing to be popular? What you'll notice over here, however, is that before this one takes off in the mixing population, it's got about 30% traction, and then it explodes. Nothing else competes with it after that. Right? So if you thought that the critical mass was 30%, because that's what's signaled here in this particular data, you'd go over here and you'd say, well, these got 30%, but nothing happened. Right? They got up to 40 or 41, and then they died back down. What this tells us is that that question is not actually the right question to ask. It's not just how many people do you need to get a groundswell for a critical mass. It's how are those people connected to one another, and how does that affect the sort of collective growth? We see the exact same dynamics in the theory. And this tells us that something special is happening here. From a physics point of view, my collaborator on this is Andrea Baron-Kelly. He's a physicist, and we spent a lot of time thinking about this model and what the difference is dynamically between this situation and this situation. This is called symmetry breaking. It means that here, all the options are technically, from a physics point of view, symmetrical. And it means that anyone could win. As it keeps evolving, anyone could win. And as those border regions are competing with another, they can expand or they can collapse. We just don't know. What happens in this case is there's a breaking point. And once that breaking point is hit, nothing ever returns. And so dynamically, it looks like this. You see basically the distribution of options in the population. No one is that much greater than anyone else. Whereas what happens here is you start to get a big winner. And over here, you have a distribution that's significantly more steeper than this ZIF. And what that means is that there's one huge winner and a bunch that have died out. So when we looked at this, and tried to evaluate what was going to happen in larger populations. Our model said that above a population size of 20, this thing generalizes to an infinite population size. But of course, it's interesting to show that empirically. And once you get results that look like this, that look just like your expectations from the models, it's tempting not to do anything else. I mean, there's a kind of excitement and terror that happens when you get the results you're looking for, which is, should we run it again? Right? And you're almost inclined not to run it again because you have it shouldn't match that perfectly, and expectation, the thing you do next won't. So our goal here was to increase the population size just as kind of an intuition, as a test of what would happen next. So we doubled the population with n equals 48. And this was striking to us because not only did the dynamics look the same, but they were actually on the same time scale. So this is even faster than we would have expected by our models. And so we did this again, and this was again terrifying. We decided to double the population now, so we had 100 people, 100 strangers, show up to a website and interact for a few minutes online. And at the end of that process, we got complete convergence across the population. So by 30 rounds of interacting with each other, we had essentially people had created a new social norm. Now the remarkable thing is that's with 100 people, but if you put 24 people, a much easier problem to solve, in a different network structure, they couldn't figure it out. Right? So it really tells us there's something about the way the structure affects this. And so when we replicated this, each of these different networks, each of these different sizes, we see just a consistent result. So this is a 0.01 significance with n of 12, by the way. This is many hundreds of people, but we're just evaluating over the networks, not over the individuals. So with n of 12, we show a significant difference on the way that social structure creates the possibility for big winners to emerge in society. So one interesting thing, and this is in closing, is that someone once said to me, well, that's interesting, but you got names like Michelle for the women and names like John for the men. You could never get a name that would be a weird name. You could never get a name. And he was a white male. He looked like that guy. And he said you could never get a name like Shaniqua for me, right? And so that was a challenge, right? Because the whole point of this study is to show you that these norms really just emerge through a social process. There's no sort of clear division in what norms are or are not possible. In fact, any norms are possible. So we ran this study, and you can see there's 4 names that we sort of select here that we show on this grid. And the question is, well, what names are possible? What could show up? And this was the answer. So you can see that the red one is the one that wins. It's actually Nia. And at the beginning, people were using Eric and Sean and Hans. And even these people who were pushing those options, at the end, all wound up saying this name that's an incredibly weird name for that, given sort of our normal social conventions, which tells us something more generally about the capacity to do this sort of thing, not just in society, but in the online space. What kinds of social norms and conventions can we mobilize? And this kind of motivated a new set of questions, which is what we're working on now, is how easy is it to do this? How easy is it to take an existing norm and actually overthrow it from a kind of a committed minority perspective? So the kinds of things we're thinking about now are emergent gender conventions and status norms. What kinds of traits and characteristics are perceived to be high status versus low status? right? And what kinds of changes in the sort of everyday conventions that we use could actually be mobilized. And we're focusing some on diet and health, opinions about vaccination, right? How easily could we control opinions about vaccination versus one person in Marin County who gets on the news, right? And furthermore, what about opinions about climate change, right? And beliefs about the accuracy or inaccuracy of reports on global warming. And we're also looking at this problem of optimality. That's an incredibly interesting one, because everything I've talked about right now is for an arbitrary social norm. There's no right or wrong in the kind of collective answer that emerges. However, we really care whether or not people, once they converge on something, are making good decisions, right? And again, the medical decision-making thing is the obvious one, because we've got lots of people interacting online, forming sort of conventions and beliefs about what they should be doing, and that may or may not be the right thing. And so we want to know if the kinds of networks that are controlling this process are actually helping to foster the right answers emerging. And then finally, as I said, we're interested in this process of mobilization and whether or not you can control this, not just through the structure of the network, but through sort of focused interaction at the beginning of this process. So the question that we were sort of starting out with was, can social change or the emergence of social norms take place over a very large population without any institutions or any incentives governing this process? And the answer not only is yes, but it's yes in a very specific way. It's that it really depends on how people interact with each other. And we can control whether this process succeeds or fails. And now we want to know whether we can control to what degree the norms themselves that are selected are governed by small groups with interested agendas. Thank you very much.